So, ladies and gentlemen, the main important thing that we're going to get to, we've talked a lot about rules of exponents so far. Now we're going to do is kind of remember going back to a little bit with combining like terms, which we've already kind of spoken about. But the main important thing is, how do our like terms allow us to simplify our expressions? All right. So we've talked about monomials, and we've talked about multiplying monomials, especially when we add exponents, right? We talked about our rules of exponents. When we multiply monomials, we add the exponents. When we divide, we subtract the exponents, right? Okay. And then we started talking about binomials and polynomials. Well, one thing we need to understand is we can only add and subtract and combine polynomials when they have like terms. So what exactly do I mean by like terms? Well, first of all, 5 plus 5, obviously you guys are pretty well versed in adding numbers. 5 plus 5, those are like terms, so we can add them up. So 5 plus 5, we know the answer is going to be 10. However, 5 plus a, we don't know what the value of a is. So therefore, these are what we call non-like terms. This is a variable, and this is a number. Those are not the same like terms. So therefore, we cannot add these. The reason why is we don't know the value of a. Some students like to say this. They say, oh, it equals 5a. No, 5a means 5 times a. So 5 plus a does not equal 5a. It does not equal 6 or 6a. 6 is a number. It would equal 6 if a equaled 1, but if a equaled 2, it equals 7. So it all depends on the value of a. And since we don't know the value of a, we just leave this as 5 plus a equals 5 plus a. Okay? It does not equal one of those two. You cannot combine them because they're not like terms. One is a variable, one is a number. So what about when you have two variables? Well, the main important thing, guys, if you remember, a variable has a base and an exponent. Right? You can combine like terms when, as long as they have the same base and the same exponent, we can add and subtract them. So do these have the same base? Yes, they're both an a. Do they have the same exponent?
Yes.
Yes, if you remember, we can write this as a 1 exponent. Now, there is no rule, Jonathan, of doing anything with exponents. If you remember, x times m times x times n equal the addition of the exponents, right?
Yeah.
Well, when we're adding, that was only for multiplication. When we're adding, you're just going to be adding them together. A plus a equals now, thank you, 2a. We don't need to do anything with the exponents. They're just going to remain the same, okay? Instead of having 1a, now when you combine them together, you get 2a, okay? For next one, for number 4, it works the exact same. These just have two different exponents, so you're going to say this will now be 2a squared. All right. Now the next thing it gets a little bit more difficult is what happens when they have the same base or they have some numbers in front. A couple things to remember. When they have a number in front, that's just representing how many of my a cubes I have. So, you know, if I say like 2a, that means a plus a, right? 3a would mean a cubed plus a cubed plus a cubed. So you can only combine when you have like terms, when you have the bases are the same, and when the exponents are the same. John, could you move back? Actually, I'm sorry. Could you move back behind Joshua? So you have them when they have the exact same exponents and the same base. So obviously, I cannot combine either one of these with my a squared. The only two I can combine are these two terms. And to do this, when you're going to be adding your like terms, yep. Okay, well then you're going to have to find another seat then. You can move over there. So therefore, all we're going to do is combine my terms in front. So negative 5 plus 3 is going to give me a negative 2a cubed plus a squared. Okay, all I did was I took negative 5 and added it to 3. So negative 5 plus 3 gives me a negative 2a cubed, and then I couldn't do anything with the a squared, so it remains there. Same thing here. These are both have the same bases. However, this is not the same base. So I can't combine my b squared with anything. I know it has the same exponent, but since it doesn't have the same base, we can't do anything with it. However, I can combine a negative 2 plus the positive 2. So what I'll do is I'll actually just rewrite that. Negative 2a squared plus a positive 2a squared plus b squared. Well, what's negative 2 plus positive 2? 0a squared plus b squared. What's 0 times anything? 0. So we ended up just having b squared being this final answer. Okay? So that's a little bit of help into the world of combining like terms.
Whoa.